Now that we know how to create probabilities and use them, we're going to move on to random variables, which are generated from probabilities but are used for making predictions. A random variable is a variable whose number value is based on the outcome of a random event. So for example, with a die roll, the random event is what number comes on top, and the actual number value is the random variable. And so what the number value takes is going to be random based on how you roll the die. We notate the random variable by using the capital letter X. And we use the lowercase letter to denote particular values of a random variable. So for example, if the outcome was 3 from a die roll, we would say the lowercase x equals 3. There are two different types of random variables, discrete and continuous. And for this class, we're going to focus on the discrete random variables because they can take on a finite number of distinct outcomes. And the math for these are a little bit easier. For continuous random variables, because they can be in a range of values, you need to know more complicated math, so you would need to know calculus. So for this class, we're going to focus on the discrete random variables. Now, once we have our random variable defined, we can generate a probability model, and a probability model is the collection of all possible values from a random variable and the probabilities that are associated with it. So an example of a probability model here is the die roll. Capital X denotes our random variable, the number on a die roll, and the lowercase x here represents each particular outcome. So if the die roll is 1, that has a 1/6 probability or a 1 in 6 probability. The same is true for any of the possible outcomes, and so it has a uniform distribution. So this whole notation here is the probability model for the random variable of a die roll. So once we have a probability model, that is probabilities for every particular outcome, we can generate a mean, a variance, and a standard deviation for that random variable. So what does that mean exactly? Well, the mean of a random variable we often think of as the expected value, and that's why this is notated with an E. So the expected value from a die roll is going to be the outcome of each die roll, or outcome of each particular outcome, times the probability that it occurs. Then you sum up all of those particular outcomes multiplied by their probabilities. And once you do that, you have the expected value of that random variable. So for example, the way this is done with the die roll is that we're taking each outcome and times it by the probability that that outcome occurs. So this is the same for every single outcome. You can see here 1, 2, 3, 4, 5, and 6 all have the same outcome. When we sum up all of this, we get 3.5. So that says the expected value of the die roll is going to be 3.5. Now we know no single die roll is ever going to be 3.5. It's only going to be 1, 2, 3, 4, 5, or 6. So what this is actually saying is that if we were to roll the die 1,000,000 times or 2,000,000 times, that the average of those rolls will tend to be around 3.5. And that's what this value is calculating for us. That is the average of 1,000,000 or 2,000,000 die rolls. Now some die rolls are going to be higher than 3.5 and some are going to be lower than 3.5. There's going to be some amount of variation, and we can calculate that variation by using this formula here, and then our standard deviation is going to be our normal metric for how deviant or how different those die rolls possibly could be. The way the standard deviation is calculated is through that variance. So the variance is the distance that each outcome is from the expected value. So you can see here that expected value is the same for all of these, and we're just changing the outcome 1, 2, 3, 4, 5, and 6. We square that difference and then multiply it by the probability that outcome occurs. So here again, all of the outcomes have the same probability of occurring, which is 1/6. So the standard deviation that we calculate when we put this formula into Google or into our calculator, is 1.71, and that represents the amount of spread there is in the values on die rolls. So now that we have a mean and a standard deviation, we can do all sorts of wonderful things that we used and learned in the last section of this class with the normal model. Remember that the normal model only required a mean and a standard deviation, and that's what we're calculating here, is a mean and a standard deviation. So the final goal of this is to use the normal model to generate predictions for this random variable, whatever this random variable is that we define. Here it's just a die roll. But in the next set of videos, I'll go through a bunch of other problems where we define random variables in all sorts of ways and generate new probability models. And so you can see how I calculate the mean and the standard deviation and some of their really interesting properties.